Hi, I'm Ming-Chi and this is the video explanation for homework 7, question number 8. And for this question, we are given 3 points of a Poisson process. Well, it's defined this way, which is first that the equation of this and t, or let's say tau, is equal to t2 minus t1. And suppose that t2 is larger than t1, of course. So that the equation is given from this. And secondly, if the intervals are non-overlapping, they are independent. And the third point is that there's no more than one Poisson point at any moment t. So, and there's furthermore a graph explaining all this. In this question, we are trying to figure out first what is expected value of xt. So to solve this problem, well, the problem is over here, and to solve it, we know that there are some given facts. First, we have the Poisson equation. Is the Poisson probability equation is right over here. We also know that the distribution function, let's say, of Poisson is the sum of it. Well, anyway, equals to 1. So this thing is equal to the sum of the for all k of this equation. So there's a sum here. There should be k equal to 0 to infinite. And we are to find out expected value of that, which for expected value of that, is basically we're trying to figure out the k e lambda and k e negative lambda and lambda k over k factorial. And so in order to figure that out, first step, we can move this negative lambda, e to the negative lambda, to the left-hand side, which is a 1. So it becomes e to the lambda. Everything on the right doesn't move. And take the derivative of it. And after taking the derivative, left-hand side stays the same. Right-hand side, we get this. So here we have lambda to the k minus 1, which the entire thing is timed by another lambda. Left-hand side and right-hand side both, we have this part, and lambda to the e to lambda times to the e to the lambdas. And taking this to the right, there should be a negative sign over here, and I should remember that. So here is basically what we're looking for, is the expected value of x of t, and lambda is equal to that, and that's everything we need to know. So for part 1, everything's finished. Oops. Here are all drawings. For part 2 of the question, we are to find out are t1, t2, which in the y sense stationary process, we have r of this, or well, we actually what we need to do is to figure out the autocorrelation equation, which is this. We don't need this. What we need is this. And there are actually 2 cases. So basically, when t2 is larger than t1, so let's say that t2 is larger than t1, right? And we can say that t1 is t2 minus tau. So xt1 is in the front, xt2 is in the back, and we calculate the expected value of this, we get the autocorrelation. And in order to do that, oops, here are our drawings. In order to do that, we can make this into this. So it's basically minus x of t1 plus x of t1. This entire thing equal to 0, so that doesn't matter. But it will help us solve the equation. So by multiplying things into there, we have this part, and this part, which the most important, I guess, is that we have this thing with this, and this is the same. So this thing times this part and this part plus together, and plus whatever this is. And after that, we can further write everything down into this condition, which this part is basically just lambda t. Well, it's already written here. It's this part. And for the left-hand side, it's written like this. And to further solve this down, we have this equation. And by multiplying this thing to this thing, and then outside, we have a negative lambda t1 squared and a positive lambda t1 squared, which is right over here. So that's why we need this. And solve this equation, we get this part. So this is the case when t2 is larger than t1. So what's the case of t1 larger than t2? We just swap the where the t1 and t2 were, and we know that we swapped these two, but everything else stays the same. So whatever in our final equation, t1 and t2 are swapped. So it's easy to get that the final solution of this is just swapping the t1 and t2's place. Lambda remains the same. The plus sign remains where it is, and that's everything for us to do to solve this question. And that's it.